Test 2, 3. Test 2, 3. Check 1, 2. Test 1, 2. it's just, we need longer cables. Yeah, there's one right in front of that air conditioning.
Guys, we're gonna just start in about 5 minutes. We're gonna give people a little bit more time to get up here. And you're all empowered to set your machine up for being late. develops nationally recognized standards for lighting control. She is a professional member of the International Association of Lighting Designers, ILD, and is among the first professionals in the world to earn the Certified Lighting Designer Accreditation, CLD, having demonstrated mastery in 7 domains of lighting design as established by the CLD Global Organization and the ILD. Ms. Siegel is a senior designer at Heartraft Lighting Design. Welcome.
Gee, thanks. Okay. Thank you. All right, as previously discussed, we're going to be talking about acoustics today, okay? All right, so here's the part. Oh, they did fill it in. Good. Honestly, oh no, it's just a placeholder. Okay. If you need AIA credits, you can get them after this. You need to turn in your number, blah, blah, blah. Here are the things you'll be able to do at the end of this. You'll be able to fly planes, cook like a master chef. No. So we're going to talk about the basic components of a control system. We're going to understand what lighting control systems do, and we're going to talk about how to recognize control information. This is a basics class. So there is no, we're going to actually talk about the difference between occupancy and vacancy. We're going to be very, very sort of weedy about this so that we can sort of demystify this process a little bit. So when we're talking about control, what are we actually talking about? We can be talking about really carefully crafted visual environments. Here are 2 different examples. We can be talking about lighting that's used to enhance wayfinding or to convey information. We can talk about, we could be talking about modifying the outputs and the intensities of different types of fixtures from different types of manufacturers so that they can all work seamlessly together. Control can mean energy compliance. We've all seen these lovely documents. We love them, don't we? Or it can mean having luminaires respond to exterior stimuli to help us stay entrained to our exterior environment and keep our sleep cycles on track. Control can be integrating lighting with HVAC components for automatic demand response, or ADR, when the HVAC in a space shuts off or turns on depending on the occupancy from the lighting control. And lighting control can also be integrating with AV or other systems, right? So we're going to look at how and why in a minute, but let's look at what just very basically. So in the past, the relationship between control components and the mechanism was very, very straightforward. There were actual pieces of wire, right, that went from the control component, in this case the switch, to the light bulb. And control systems, such as they were, again, involved pieces of wire that went to specific loads and were a physical connection. Zones were also grouped by this way, right? So it used to be, for example, that if you had 2 fixtures wired together like this, they always had to twin. They were always operating together. And this yielded some really super attractive installations. No questions here, right? Everybody's good? Okay. All right. Many of the control wiring schemes that we use today are holdovers from that previous era of control. And you can see that by noticing that we're still looking at physical wires, gray, purple, black, white, and green, gray, purple, black, white, and green. Here's a little LED. The driver is now standing where the fluorescent ballast used to be, right? We still have a switch. This relay can be anything. It can be an occupancy sensor. It can be a daylight sensor, whatever. But you can see this is basically pieces of wire running between pieces of equipment and pieces of lighting. Everybody following so far? Please stop me, by the way, because we're a very small group, as you can see. And this is going to be really boring if you just listen to me talk for an hour and a half. Okay, so current digital technology allows for both wired and wireless communication systems. So on the left, on the left here, we have a DALI bus loop. And you can tell that because it says DALI. I don't know if you can read that. It's a very blurry slide. I apologize. But basically, here's a cove light in a conference room. Here's some downlights, right? And the projection screen, they're not actually all wired together, although some of them are. And then over here is a diagram for a wireless cloud-based control system. So we can talk to, because we now have little computers in all of our lights, we can actually talk through Wi-Fi or Li-Fi or all sorts of other wireless technologies, some of which we can talk about, I guess. The point is that we don't actually need physical wires, and this is actually a good thing because it frees us up to combine and recombine sort of on the fly as we go on. The thing is, we still have the same basic components, right? We have light fixtures, we have sensors, we have switches. These light fixtures, by the way, are on display downstairs. And they're very, very cool, and you should go look at them. They're fully declare label, red list free, totally awesome. Okay, sensors can be integrated into the fixture, or they can be standalone. And we're going to talk for a minute about occupancy and vacancy sensors. We have basically two kinds, right? We have, going back. We have passive infrared over here, and we have radio frequency. They both basically work on some level in the same way. That is, they put something out, they wait for something to come back and bounce back, and then the electronics inside the sensor analyze what that means, right? So with a PIR, it's just like the remote, the old school remote, where if you stood in front of it, the remote doesn't work, right? So they're putting out an infrared signal, and if it makes connection, then they know that the space is not occupied. If it doesn't make connection, they know the space is occupied, and we'll talk about what that means in just a second. And then with ultrasonic, sorry, it's apparently still early for me. Ultrasonic, it works a lot, very similar to the way that sonar works, right? Sends out radio waves, easy for you to say, and depending on what bounces back, determines whether or not the system is empty or occupied. So I want to talk for just a brief minute about why it's important to not to always use, but to default to a dual technology sensor, okay? So, and here's the very easy answer to that. Restrooms, okay? So in a dual technology sensor, well, let's just imagine for a second, we don't have a dual technology sensor. Let's just imagine that we allowed our electrical contractor to select our sensor for us. Boo hiss. Not contractors, just letting them do something that they're not trained or hired to do, okay? We love contractors. Contractors are our friends. However, they are not specifiers, okay? So let's just say that we went ahead and we let the contractor select our sensor, and they put a wall-mounted infrared sensor on the wall in the public restroom. Why is that a bad thing? There you go. Infrared cannot pass through the bathroom stalls. So we have two options. Option one is, and I actually use both options because I'm a belt and suspenders kind of gal. Option one is to, in your control intent and in your sequence of operations, have one load in the bathroom. In my case, if you happen to be in a commercial restroom that I've designed, it's the slot along the wall that never goes down to less than 30%. Ever. Room is empty, slot is on at 30%. We'll talk about why that's important in a minute. So that's option one, that's the belt. The suspenders is a dual technology sensor. What does a dual technology sensor do that a passive infrared sensor can't do? It can read through the bathroom stalls. Why? Because it's already determined what the empty room sounds like by sending out those radio waves. Does that make sense to everybody? Okay, so for spaces that have complicated, and by complicated I mean any architecture, where did that come from? Any architecture that is other than four walls, other than the square, right, other than the cube, if you have architecture that is more complex than a cube, you need a dual technology sensor. Hands down, that's just the end of it. Any questions? Good. Okay, we're going to talk about that bathroom slot again in a minute. All right, so this is the part. Oh, this is not the part. So let's talk about the difference between occupancy and vacancy. So occupancy and vacancy are the most common means of control that we find in commercial applications. They They provide really easy code compliance. Usually it's 50% reduction in unoccupied areas. And they supplement other functions like time clocks. And either occupancy or vacancy will meet many code requirements. I said most here, that's actually probably not true. Vacancy is the preferred method for most codes. So let's look at the difference. Because there are some differences, and we should look at them. Okay, so occupancy is auto on, right? We've all seen that. That's when you walk past the hallway and the lights go on. Vacancy requires initiation, which is why most codes like it better. It's timed off. Oh, this didn't get shuffled properly. All right, well, we'll deal with that. Okay, so occupancy is auto on and timed off. Vacancy requires initiation or an interface and override. As you can see, I didn't get these quite shuffled properly, but that's okay. Occupancy does not, although you can have it. Vacancy does not have any issues with adjacency, although occupancy does. So this was a much more organized table after I realized I had messed it up, but I guess I didn't get that version here. Oops. I'm 2 for 2. Last year this happened too. All right. Does this make sense? Yes? Thank you. Okay. Let's look at daylight harvesting. This one, it doesn't have a compare and contrast, so I know it's in the right order. Although we didn't talk about daylight harvesting. That's weird. Oh, we did. Okay, sorry. All right, daylight harvesting is code required based on the amount of window or other glazing area and the wattage in the space. Okay, so that can be a window, that can be a monitor, that can be a skylight, it can be a transom, whatever it is. And the amount of energy, I believe it's usually 150 watts for 600 square feet, plus or minus. It establishes daylight control zones. So there's a primary zone and a secondary zone. That is the zone that's closest to the daylight aperture, as they like to call it, and the next zone over. And it balances the idea of free daylight and electric light, right? So that's all pretty good. And we have 2 different kinds of daylight sensors. We have open loop and closed loop, okay? So an open loop sensor takes a look at the light coming in from the window in this case. Hi, Carrie. Carrie Hawley, everyone. And adjusts the electric light in response to the amount of light coming in. What is the problem with this?
You're collecting all the light from the fixture as well.
Yes, right? Also, it doesn't allow for clouds particularly well. So in a closed loop system, which is, again, sort of a belt and suspenders kind of approach, the sensor looks at the work surface. And you set a level for the work surface, and then the sensor's job is to balance the exterior light and the light fixture. Does that make sense? So again, I think that the important thing about closed loop control is really, you want to look at what you're reading, right? So if you're just using open loop, it's kind of simple, but the problem is you're not looking at the surface that's really important. You're just looking at how much light is coming in, and you're saying, if X amount of light comes in, this is what the electric fixture wants to do. And I guess that's okay for a hallway, for example, that has a glass, like if you're in one of those big glass towers and you've got like a long passageway and there's no visual task going on. But if there's a visual task going on, what's important is the amount of light on the work surface, not the amount of light coming in, and that's what you want to balance, okay? So daylight harvesting does have a couple of sort of hinks that we need to look at a little bit, okay? There are override issues, right? If you have any kind of shades, if you have any kind of exterior fenestration besides shades, right? If you have some sort of daylight fin on the building, all of that can be a little bit complicated to sort of work around. You can't control clouds, so you need to be sure that your timing on your fade rate, right? The amount of time it takes the light to go from the darker output to the lighter output, or the less intense output to the more intense output, or vice versa, has to be relatively subtle. Otherwise, the lights are flashing on and off, and that's kind of disconcerting to people. And then there's the problem of missing teeth. So I couldn't find a really good image for missing teeth, which is why we're looking at this one, but I'm going to explain this. Imagine, you see these are 1x4s, right? These are a common symbol for a 1x4. Now, instead of imagining 1x4s recessed in a ceiling, which is an ick way to design an open plan office anyway, imagine these are really lovely direct and indirect fixtures with like a really nice upward glow and a really good task component, and they're really lovely and small and it looks really sexy. Now imagine that these lights over here, or this light over here, right? I'm pretending, you're all pretending with me, that this is one long fixture, this is another long fixture, this is three long fixtures hanging over an open plan office. You guys are all with me? Okay. So this fixture is what? On, off, partially on, partially off. What is it? Bueller? It's full on, right? It's full on. Why? Because it's outside of any of the daylight zones, right? I should have stopped and clarified what we were looking at, right? We're looking at a primary side lit zone, which means windows. We're looking at a secondary side lit zone, which means windows. And we're looking at a skylit zone. I hope that was clear, but I apologize for not clarifying it before we went on with this little tangent. Okay, so in my second line of fixtures, what's going on? This half of the fixture is on somewhat, and this half of the fixture is probably not on. So now imagine, if you will, my sexy layout with my open plan office, and I have my uplight. Okay, and let's just say that I had enough energy to keep the uplight on regardless of what the sensors were doing. So at least the ceiling is uniform. But what do the desks look like? Blotchy, yeah, right? So because over here, while it's cool that this is all lit by daylight, right? Over here, it's entirely possible that this is a completely different feel, right? Because you've got electric light and daylight, and it's totally different. And then in the primary side lit zone, which also happens to interact with the skylit zone, you've got a really weird thing going on because these lights may never come on until 3 o'clock in the afternoon in January. So for like 3 months of the year, you might have all of your lights on at the same level, but for most of the time, you've got this really weird pitchy-patchy thing going on. So the way to, I don't have a magic bullet for fixing this, but what I will say is that a closed loop system will at least mitigate some of this, right? Because the closed loop system is not just saying this is how much light is coming in. The closed loop system is saying this is how much light is on the surface. That being said, this is simply an issue with daylighting that nobody has really figured out how to solve because it is what it is. This is why codes are complex and difficult. And this is partly why it's important to understand control and important to understand how you specify your control system so that you don't end up with sort of a patchwork of illuminances across the space. Is that everybody following along there? All right. So let's talk, we're going to leave daylighting and talk about circadian lighting for a minute. All right. So we all are aware of this, right? This is not coming as news to anybody. First of all, it shouldn't come as news to anybody that right about 3 o'clock, everybody needs a snack and a cup of coffee. I do. I mean, 100%. 3 o'clock hits, I'm like, ooh, it's time for carbs and coffee. It's my favorite part of the day. All right, so what we don't often pay attention to, and we all do know that, right? Because everybody knows that the worst meeting is the one that starts at 2, right? You're not bumped up from lunch anymore, and you're an hour out from carbs and coffee, and now you're gonna sit and talk about something really, really thrilling. Never. Okay. So we also know that the color of daylight shifts across the 12 hours or so that we are awake every day, right? This comes as no surprise to anybody. And we know now that if we can tune the lighting in our interior environments so that it more closely matches what's going on outside, it helps us sleep better. And when we sleep better, we're less grumpy with our spouses and children and bosses and coworkers, and that's always a good thing. Also, we have less headaches, we have less weight gain, less cortisol. We know all of this, right? Okay. So what we also know is that a large part of this is, the largest part of all of this awareness is part of the non-visual photoreceptor that was has been discovered within the last 20 years. Everybody knows about the intrinsically photosensitive retinal ganglion, yeah, thank you. IPRCG, yeah. Yeah, they teach it in preschool. It didn't exist when I was in high school, or even college, to be perfectly honest, but they teach it in preschool. How cool is that? If anybody tells you that lighting is not relevant, that lighting is not important, you can say to them now, and you can remind them, that's actually a really good point, that they teach in preschool something that lighting designers discovered and figured out that didn't exist when everyone in this room was in school. Amazing. All right. So circadian lighting matters. We understand that. And we do know that if we support circadian entrainment, we get better results. And this is just a really nice picture from a manufacturer that makes a fixture that comes out of the box pre-programmed to do this kind of thing. Now, I'm not suggesting that this is the be-all and end-all of lighting fixtures. I happen to think it's a lousy industrial design. That's just my own personal opinion. But what is important is you can see the color of daylight shifting across across the day. All right, now we're gonna look at some samples. All right, so I'm gonna actually not have a blank screen. We're gonna get back to, I am gonna still have a blank screen, sorry. All right, we're gonna talk about this in a minute. But first, it's time to play Vanna White. Okay, so can you guys see this stuff? I apologize that I don't have huge huge samples here, but you kind of get what you get. All right, so what we've got here, okay, we've got 2 wafer downlights. Multifamily specials, we love these. Okay, we have an occupancy sensor and we have a vacancy sensor. So, the occupancy sensor, I'm not gonna point these at you because they're glare bombs. Here's the occupancy sensor, right? Something happens in front of the sensor, the light says, ooh, something's happened, I'll go on. Let's talk for a minute about why that's less than helpful. Other than the fact that it just hit me in the eye, which is, less than helpful. We talked about how we have issues with adjacencies, right? We've all seen that. People say, I don't want any sensors in my office because every time somebody walks past my glass wall, my lights will go on. Well, that is, in fact, something you can protect against, right? This particular sensor does not have a shield, but you can get shields, right? Which will cover a portion of the sensor. You can also, program the sensor to not pop on, or program the light to not pop on once the sensor is activated. And you can use vacancy. So here's a vacancy sensor. This one happens to be, a hallway sensor. Well, that wasn't supposed to happen. Try that again. Okay, so nothing happens. Pretend that first one didn't happen. Right, here's our hallway sensor, nothing's happening. In order for it to go on, we have to initiate something. Now, what's super cool about this is that this is a wireless little setup. You can also see this downstairs, by the way, in booth 309. So this is just a wireless switch plate. It's tied to this. I really can't tell you why the magic works, but I can tell you that it does work. And you can shut it off and turn it on, as long as the sensor has been activated. Okay? So this is why codes prefer this over occupancy, because there's less chance of the sensor being activated or of the light being initiated without there actually being occupancy in the space. Does that make sense to everyone? It does save energy, and that's what codes care about. So here's the problem, not the problem with codes, the fact about codes. Codes are not about design, codes are about saving energy, which is fair since they're called energy conservation codes, right? They're pretty upfront about what they're doing. And it's not a bad thing to save energy by any stretch of the imagination. I am not, please do not go home and say, I heard this speaker and she said that energy codes are bad. Energy codes are not bad. Energy codes are one of the many things, along with architecture, along with life safety codes, along with Revit, that sometimes make our jobs more challenging as we're imagining these amazing lighting installations for our clients. Energy codes, though, just like good parenting, provide boundaries within which we have the freedom to operate. And anybody in here who is a parent, which I'm guessing is a fair number of you, knows that kids without boundaries are nightmares. So are designs without boundaries. Just think of when you get frustrated by the compressed lighting power density that you have available to you for whatever project you're working on, remember that a spoiled lighting design is as bad as a spoiled child. That you can go back and tell people I said. All right. Any questions on occupancy and vacancy? You guys are so quiet. This is going so quickly. This is going to be a problem. All right.
I do have one more
Yeah.
clarification question. You said that they prefer vacancy over occupancy, and why?
They prefer vacancy over occupancy because vacancy requires initiation. So a vacancy sensor, once it's, you have to physically turn it on. In my, and we're going to talk about control intents in just a second. In my control intent narrative, it says a positive reaction is required to initiate the light or to initiate the luminaire or something to that effect. Over an occupancy. Yeah. The example that I like to use is you've left your office to go to a meeting and you realize you forgot your phone and you jump back in to get your phone. You don't need the lights to see your phone. Your phone's right there on your desk where you left it. Okay. All right. So let's talk about other kinds of control. Because it's not just about when the lights are on and when the lights are off. It's also about other things we can do. So we can talk about tunable white. Can you guys see this okay? Actually, so in this case, we have dimming, which is on one side. Everybody can see this okay, right? And then we have, color temperature, right? So this is dynamic white or tunable white. It's different from warm dim, which we're going to look at in a minute. And the thing about dynamic white or tunable white is that it requires two zones of control. Okay? Two zones of control. It requires one zone or one channel or one, I guess those are the best two ways of describing it, for the intensity, the brightness, how much light is coming out of the module, and the other zone is for the color temperature. Here is, actually, I'm going to show this, I can show this to you guys, and this one, since it's not connected, we can pass around. This is actually a tunable strip, and you can see that there are actually two different LEDs on the strip. And that is that's how all tunable white fixtures are set up. So when you look at a tunable white catalog number, for example, this one says 1835 on the back. One of these chips is at 1800 degrees Kelvin. The other one is at 3500 degrees Kelvin. And you're going back and forth between the two. You guys can pass that around if you like. And we're going to look at what that looks like right here. So here's the warm, here's the cool. Now this particular one is set up to dim the warm and the cool. You sort of get intensity within the warm and cool, okay? So this is a slightly more advanced controller than that one. So to be honest, this one is, at least this one utilizes a protocol called DMX 512, which we can talk about at some other point. DMX 512 is a digital protocol. It's an ANSI standard. The cool thing about any protocol that's an ANSI standard is you always get the same thing. Now, the reason that I like that is that because that means that if something says it operates on DMX 512, it does, and I can look up exactly what that means. This little guy, which is really cute, is a 0 to 10 volt control setup. 0 to 10 volt can mean any one of three things, and I can't tell you by looking at this which one of the three it is. I can only tell you that it works because somebody actively put together a little box for me that says one side is intensity and one side is color temperature. But I can't tell you what's actually happening from an electrical engineering standpoint here, which is okay because I probably couldn't tell you what was happening from an electrical engineering standpoint anyway, because I'm a theater person, and electrical engineers are kind of like these magic people who walk in straight lines, and theater and other lighting designers, we do circles, we do pretty pictures, okay? So nonetheless, we have a control that is intensity here and a control that is color temperature here, which is different fundamentally from here, where I have two zones of control. One is warm and one is cool. Thank you. Does that make sense to everybody? Ish? Okay. So now the third thing I want to talk about from a control standpoint is warm dim, which is different from dynamic white. All right, so hold on, let me turn some of this stuff off. It's off, okay. So, in warm dim, as I make the light get dimmer, it gets warmer. Does everybody see that? Now, the truth is this should look pretty non-impressive to everybody, pretty much everybody in this room, because we're all old enough to remember when everybody's dining room did this. Well, almost everybody in this room is old enough to remember that. And if you're not, think about going to your grandparents' house. Right? So here we go. This should look pretty normal to almost everybody in this room. This is what happens when things dim, right? This is not what happens when things dim. What happens when things dim, hold on. Well, I just don't have four hands. What happens when things dim is this. It gets less, but it doesn't get warmer. Everybody see that? And I apologize that this is not, oh, I can pick it up, okay. Everybody see, this is just the same thing, just less of it, right? Which is fundamentally different from this, right? Okay, so now let's talk about this for a minute. If this is so nice looking and so comforting, why don't we use it all the time? And why am I standing in front of the projector and blinding myself? Anybody have any idea? Well, any of these things are going to be slightly more expensive, but there's another reason too. Nobody? Okay. The problem with warm dim is and manufacturers love this. The problem with warm dim is you can only use one manufacturer's warm dim on any project. So let's just say, for example, that I had this, whoops, and we'll pretend this is a warm dim, that I had this as my under cabinet fixture, and I had this as my downlight in a kitchen. How am I going to get these two to match? You can't. You just can't. You can get close, but you just can't. And the reason is, there are many reasons, but the main reason has to do with the color rendering and the spectral power distribution of the various sources. And for that, you should come and hear Tony Esposito speak next, because he's a genius and he invented the way to measure it, and it's amazing. That being said, you cannot get two sources from two different manufacturers that have a pre-programmed dimming curve like this, right? What's the highest and what's the lowest, they will never match. Now, in some cases, that doesn't matter. Some people don't care, right? Somebody might not care whether their under cabinet fixture looked like this or this next to their downlight. But I guarantee you that the person who has Carrara marble on their floor or whatever, or their backsplash, they do care, because they're spending thousands and thousands and thousands of dollars, and even if they can't articulate it, and they can't tell you that they care about it, they will know that something is off, and they will not be happy. So, warm dim is problematic for those reasons. That being said, full-on color tuning is more expensive. Now, I have my own theories about whether or not dynamic white needs to be as much more expensive as it is, because a manufacturer will tell you that the reason that this strip with the two different color LEDs is more expensive than some other strip with one color of LEDs is that I need more diodes, it's more complex to put it together, blah, blah, blah. I'm going to tell you that this roll here is full of tape and extrusion samples, and that every one of them has the same number of LEDs on it. And therefore, the chances of it being really twice as expensive to put it together more carefully as opposed to less carefully, I don't really buy it. That being said, I'm not in charge of the market. I'm just in charge of my specifications. Okay, questions on any of these, the mechanics of any of these? Everybody good? All right, so let's talk about how we get this on a project. And okay. So, we are going to talk about 3 different documents, briefly. The owner's project requirement, or OPR, the control intent narrative, and the sequence of operations. So each one of those has its own set of goals, okay? The owner's project requirement, which is written by the owner's team, sometimes in collaboration with the architect and sometimes not, tells you the owner's brief. What is it the owner thinks you're building for them? I want a 40-story office tower with this whiz-bang thing and that whiz-bang thing and 16 other things. Or I want a hotel with the following requirements in my food service applications, my food service locations. The control intent narrative, which is written by the lighting control specifier, which is not always the lighting designer. Could be the rep, could be the vendor, could be the contractor, could be a lot of people. That tells you, and I am 99% sure that this is the wrong presentation, but that's okay, we're just gonna go with it. Tells you what the system is supposed to do. It tells you, for example, that the restaurant will switch from the lunch look to the dinner look 2 hours before the program time of dinner service starting. Make sense? And then the sequence of operations, which is also written by the lighting control specifier, although is always carried in the engineer's documentation, tells you how that's going to happen. It says the system time clock shall blah, 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 and these things will happen. Okay? Oh, and look, here, I had a slide that said that already. So why is the OPR important? It's important because it tells you what the owner thinks they're getting, right? I just heard some people earlier, while I was eating my breakfast, I heard some people talking about an owner's document that nobody bothered to read, and then they got to the site to commission the control system, and oops, the system wasn't set up to do what the owner thought it was supposed to do. So here's the problem with this little document. Most people never see it. It is so important. I don't understand how it is that most people never see it, but it is, from my mind, the single most important piece of information you can get. Why? Because it's the owner who's ultimately paying the bill, and this is what they think they're getting. So the moral of that story is ask for it. And when somebody says we don't have one, I've had people say, oh, we're still working on that. In like CA level meetings, right? We're talking about when the submittals are coming in, and I'm saying, hey, we still haven't seen the OPR, when are we gonna see it? And I've had owners reps say, oh, we're still working on that. Which always leads me to the question, well, what is it that the client thinks we're building for them? All right, control intent narrative is an overview in English. Please, if you take nothing away from this, please learn that a control intent narrative is something that you write in English. It's not written in engineer. It's not written in lighting specifier. Don't talk about illuminance. Talk about brightness. Don't talk about 40-foot candles. Talk about lighting sufficient for written tasks, right? Don't talk about high-end trim and low-end trim. Talk about the brightest part and the darkest part or the dimmest part, right? Talk about things that people who are not sitting in this room can understand. Pretend you're talking to your spouse who's not a lighting person. So I used to try to explain, it took me many, many years to learn to explain to my family what it is I do for a living. I mean, many, many years. And my mother still thinks I'm gonna wake up one day and go back and be a concert violinist, but that's a whole nother story. Now, my parents are smart people, they're college professors. But when I tell you that they have no earthly idea what I do, and when I told my mom, yeah, I'm gonna go to Dallas, I'm gonna speak at a thing, and she said, oh, what are you gonna speak about? And I said, I'm gonna speak about control intent. You know, it's what I speak about. And she said, okay. That's nice, dear. In that way that moms do. You know, that way that moms have that make you feel like you're about this big, even though you're a fully grown person and your own subject matter expert. Okay, that's too much therapy for you guys. All right. When you're writing your control intent narrative, pretend you're explaining this to your mother, your mother-in-law, your Aunt Betty, somebody who has no idea what you do in and day out. If they can understand it, then the owner can understand it, the interior designer can understand it, the project manager can understand it. And that's your best hope of getting what you need on your project. This is where all the goopy goop stuff goes. The sequence of operation is part of the plans and specs that the contractor bids to, right? So when a contractor submits a bid to build something, they guarantee per plans and specs, and this is it right here, it's contractually enforceable. We're gonna talk about what that means in a minute, but it is specific. It tells you exactly what you need to do in order to get it done. All right, so how do we get started with all of this? So these topics stay the same. All three documents cover these same topics, but we're gonna talk about how that works. Okay, so the OPR is use cases that the owner wants or needs from your control system. Does it need to interact with the room reservation system? Does it need to track people? Does it need to tell people driving into the parking garage how many spaces are available in on each level of the garage? Yes, a lighting control system can tell you that. Does the owner want automatic shades or manual shades? And which is going to drive the bus in the conference room, the AV system or the lighting system? Now, the owner doesn't know if the AV system or the lighting system is going to drive the bus, but the owner does know that they want to push one button that says conference and have everything kind of go and have it all be perfect, right? And if the owner doesn't say that, then you kind of want to ask them if they do want that, because otherwise they're going to remember that other slide with the really attractive installation from all the old, yeah, that's what we don't want. All right. The control intent narrative, as I said, is a description of what the system is going to do, written for Aunt Betty. And the sequence of operations are the specific methods, the controls protocol, the wireless or the wired or wireless status of the system, and how this is going to work. Okay. So here are some questions to consider when you're writing a control intent narrative. I've left off the OPR because unfortunately lighting designers don't write OPRs. Owners and project managers and owners reps write OPRs sometimes. So we can't really do a whole lot about that except asking for it. Okay. So which spaces or functions? What types of technology? Okay, so now everything is LED, but are we using tunable white? Are we using color changing? I mean, I didn't bring any RGBW stuff here to do all whiz-bangy stuff because it's not really relevant, but it could be, right? Are we talking about some sort of asset tracking that needs to work with the lighting control system? How will people or the environment interact with the system, right? Are there daylight sensors? Are there switches on the wall? Are there apps on people's phones? I recently did an office project where I believe the end result is that in the touchdown rooms, people are going to scan a QR code and control the lighting from their phone. Super cool, but you have to know that in advance, otherwise it doesn't happen. How will I know if it's working? What are the things that I'm going to look for to know that I've actually done what I said I was going to do? And here's a really good one. How will someone else? So why is this someone else one important? Because for LEED, one of the most important points in LEED is enhanced measurement and verification, or commissioning. You cannot commission a system if you don't know what it's designed to do. Commissioning is not about startup. Commissioning is about making sure that what the system was designed to do, it is doing. And to do that, you need measurement and verification. And you can't have measurement and verification if you don't know how somebody else is going to measure it. Does that make sense so far? All right, moving on. Maybe. Okay, so how do we do this? In a private office, we have a question. What happens when people leave their office? The lights turn off. Well, that's pretty straightforward. And what are the controlling variables? Time of day and the length of vacancy, right? So when somebody leaves their office, if nothing happens for 10 minutes, the lights go off. All right. So shockingly, what the owner says about this is, just give me whatever I need to meet code. Here's what the control intent narrative says. When people leave their offices, the lights will turn off after 2 minutes. That's pretty straightforward. Aunt Betty can understand that. Here's what the sequence of operations says. Private offices shall be equipped with ceiling-mounted vacancy sensors. So now, here's a couple things. We've said where the sensor needs to be placed. Why have we said where the sensor needs to be placed? I'm sorry? Oh, sure. Why do we care where the sensor is? Yep, that's one reason. Also, as it happens, switch-based sensors tend to have a much well, it's not really that much of a surprise. I think I don't have a switch-based sensor here, but you can imagine, and this is going to go on, these two sensors are different shapes. So they have different coverage patterns and different areas of sensitivity. Now imagine that this sensor lived on here, right? It's a little teeny, we've all seen those little teeny sensors at the bottom of switch plates. They're little teeny sensors at the bottoms of switch plates. It's not that we can't know, because we could look at the cut sheet and it would tell us, but the range of view that that sensor has is very different from the range of view that the sensor up there has. So if it's important to you how the occupancy in the space is being read, then you want to take a minute to tell people where to look for the sensor. Now, I will also tell you that this is one of the places where it becomes really important for lighting specifiers and electrical engineers to get to be really good and fast friends. I always say at a kickoff meeting, when I talk to, usually they bring the whole MEP team. There's one person from the MEP team on the call, and there's the lighting designer. And I say to the MEP person, who's almost invariably a mechanical person. I was going to say mechanical guy. I didn't want to be gendered, but the mechanical person. Invariably, I don't know why. Anybody work for an MEP firm who can explain to me why it's always the mechanical person who comes to the project meetings? I have no idea. It's never the electrical designer. But I always have to say to them, who's your electrical designer? And they say, well, what do you want to know? And I say, because I need to be best friends with them. I need to be best friends with the electrical designer. Why? Because as the lighting designer, I have that CLD thing. It's all very exciting, woohoo. I'm not a licensed professional. I don't sign and seal drawings. I can't stamp anything. I can sign a ComCheck report, but woohoo, that's very exciting, okay? So it's the electrical engineer who's gonna take my information and integrate it into their drawings. So that's why I need to be best friends with them, because really what I'm doing is half of their job, sorta. I mean, I'm not counting up circuits, which is good, and I'm really grateful for that, because I hate counting up circuits. Does that make sense to everybody?
I would also add, as far as
Yeah.
the ceiling mount versus wall mount goes, you're measuring a 3D space. And
Yep.
you're measuring tangential movement through those for PIR only.
Uh-huh.
So you get a much different reading, somebody walking past one on the far side of the wall away from the sensor, 360 degrees.
That is a very, very good point, and thank you for that. All right. See, if I would look to my left, I would see that I had more information here. There are two statements. So, not only are private offices equipped with ceiling-mounted occupancy sensors, whoops, or vacancy sensors, but the sensors shall operate with a 2-minute time delay. Now, these 3 letters here, this 80J, this is a magic bullet, okay? Because this is still a contractually enforceable document. So why does that matter? Because what if I decide 6 months later, when this, or a year later, when this gets installed, that I don't want a 2-minute timeout, I want a 30-second timeout. Maybe it's a crazy office where people are just packed in there like sardines pre-COVID, or maybe I want a 5-minute timeout, right? Why does it matter whether or not I've put those 3 little ADJ letters there? It matters because since this is a contract, it's entirely possible that without it, somebody could say, oops, I only have to program your sensors once. That's an ad service. There's a change order attached to that. So, in order to protect ourselves, because the whole thing about writing a specification is that it is not only are you telling somebody what it is you want them to do, how you want them to build what you've come up with, you're also protecting yourself and your client for all the things that could possibly go wrong, right? So when you write a specification, you want to think about, what if I'm not right? I think about this all the time. What if I'm actually, okay, maybe not wrong, but not as right as I think I am, right? So that ADJ, which stands for adjustable, allows me to go back and say, nope, I told you it might not be 2 minutes, and you're going to have to work with me until we can get it right. This is also really helpful for punch list stuff, too, because I'm sure this never happens to anybody on their jobs, and certainly never happens on mine. You come through, you do the punch, and a week later you get a call from the client that says, something's not right. The office is blah, 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 blah. Joe says that when the assistants walk past his office, his lights go off. Nobody's ever gotten that phone call, right? Never happens. So as long as you have that adjustability built into your spec, you have the opportunity to go back and make it right without having to cajole people to do it out of the goodness of their heart. Because let's be honest, nobody does anything on a construction site out of the goodness of their heart. All right, let's look at some hallways. When are the lights on? That's a pretty decent question. All right, so the hallways are lit during occupied hours. What happens at night? The light comes back on for security sweeps and maintenance, right? So you've got an office building, you've got somebody who walks the halls at night, you've got the cleaning crew, whatever. Shocking. What does our owner say? Just meet the code. All right, so here's our intent statement again. Hallways are lit during occupied hours, and the lights come on, they come back on for security sweeps and maintenance. In my control intent narrative, I actually write 2 paragraphs. One that is based on a time clock, knowing that the sweeps are gonna come, every hour, or that the cleaning people are gonna come at a specific time. And then I have a big in the middle that says, or, and then I have a whole occupancy statement. Why? Because I don't know. And there's a statement that says pending input from the owner. So, that's the way that I handle it. It doesn't always work that way for everybody, but all right. So as you can see, there's a lot more going on in the sequence of operations. So And I've crafted this so that it sounds a little more specky, just to be, well, specky. All right, so luminaires located in hallways and general circulation areas shall respond to time clock cues, energizing automatically at the start of the workday and reducing to a lower nighttime level during evening hours. So within this, I've already specified a couple of different pieces of equipment simply by saying this. I've said that there's a time clock, which means there's a computer in this current language. It used to be that there actually was a time clock. And I have had people, I actually, not too long ago, somebody made a submission for a manual time clock on a system. And I said to them, why did you, like, what is this? What is this manual time clock of which you speak? And they said, well, you said you needed a time clock. And I said, it's a computer. Computers come with clocks. And the person making the submission said, well, how did I know that? And I said, open your laptop and look in the bottom right-hand corner. Does it tell you what time it is? Every computer in the world tells you what time it is, even the little teeny tiny one in the lighting control system. Nonetheless, so this now means, when I say time clock cues, what I've said is there's a computer system here. It's not just occupancy sensors. And the truth of the matter is that even this system, which is in fact just a sensor-based system, this is the entire brain of this system. I can't really pull it out because it's hardwired in here, but I'll do it this way. Oh. Okay. You can see that little blue box in the middle there? That's the brain of this system, but even it has a time clock, if I need one. Okay. Moving on. And then I've given you a little bit of language about occupancy cues. So the luminaires shall energize with operation of a key switch or an occupancy sensor. Again, I'm still like leaving as many options as I can so that as things develop, they can be struck out of the document, or if things develop in a way that I'm not expecting, I can come back and things can move on and we can get in the right place. All right. So there are a lot of people who get confused about the difference between these two, so I want to make this point a little bit forcefully. Control intent narratives are descriptive, and sequences of operations are really, they're prescriptive. They're very specific. 30-foot candles, or in this case, 30 lux, right? If you really want to get specific about it. And you want to always use the word shall. The only verb that is contract, I don't know why this is, and I'm sure that there is somewhere out there, there's a lawyer who could tell me, but I know this to be true. The only word that you can use in writing a contractually enforceable specification is shall. Do not use will, do not use should, do not use must or may. Use the word shall. There's something specific about the imperative shall that makes it work. It's like the secret sauce. Trust me on this. I've done enough of these talks and had enough people come up to me and say, shall is the word to use. Also, it makes you sound very grown up and authoritative, so I like that too. Okay, a couple more details. General descriptions, right? And a general description of the control system, and a preliminary description of the lighting control events for each space type, as opposed to the equipment requirements, right? So you could say this is going to operate on a DALI bus, and that gets you to a DALI system, but it's here on the sequence of operations side that you start describing how the circuits are loaded for DALI, or that you should refer to the DALI manuals to know that you load up your circuits from the top to 1,500 watts, or sorry, 1,200 watts, and then start a new circuit. Does that make sense to everybody? All right. Okay, so why is this important? Here we go. Here's the control intent narrative. Wall switch at each entrance providing on-off and dimming control. Energy code compliant. Auto on in each zone to the last lighting level. Automatically turn off all lighting when unoccupied. Daylight responsive controls and emergency lighting. Is that all right? So here we see sort of how it works out. The general lighting This is our daylight stuff right here, 600-foot zone. Here we've even called out what the zones are, the last light level, manual on, right? Okay. And here, automatically, so we're going to look at just this statement. Everybody see where we're going with all this? All right. So fortunately for us, there's a standard. I mean, you don't have to remember any of this. You can look it up. So this is an IES book. It is, the IES is part of the, is an ANSI standard organization. So what does that mean? The American National Standards Institute, their job is to define things. That is the whole reason this group exists. And the IES is a participating organization. So that means that this book, which is called Documenting Controls of Intent, Narratives, and Sequences of Operations, was developed by a consensus committee. The reason I provided this link is because if anybody wants to understand how consensus committees are put together, that's where you go to look it up. It's a lot of verbiage, but it basically means that on the committee that wrote this book, of which I was a part, there was an even mix of end users, manufacturers, governmental people, engineers. It was not written the way some things often are in our capital by lobbyists, for example. So the ANSI standards process, the process of writing the book and the public review, and the fact that we had to be acknowledged domain experts means that what we say, at least theoretically, should have some weight and should provide some level of confidence to people using it. So this is a little bit of the description of the introduction. It gives you a little bit of an idea of what it is that the book was designed to do. And I just want to, whoa. Well, let's go back for a minute. Here's what it looks like, okay? I just want to stop for a minute and also say that anybody who is a member, well, anybody who has not sat on an IES technical committee, if you're a lighting person in the middle of your career, you've done this for 5 or 6 years, you're ready to kind of do something really to sink your teeth in, I highly recommend joining an IES technical committee. It is very, very difficult work. It is very, very time consuming, but you learn so much, and most importantly, you will then know people who know what you do even better than you, and you will be able to call them, right? I can call people who actually understand all 3 types of 0 to 10 volt and say, so my friend Mitch, who sits on this committee and works for Signify, that's what we're calling it this week, right? Works for Signify, I can call him and say, Mitch, could you explain the 3 0 to 10 volts again to me, and why, and how, and what? And Mitch, who is a very dear friend, will in fact take 20 minutes out of his day and say to me, you know, Shauna, we've done this before. It's really kind of old, but he'll explain it to me. And I get that as having, it's the benefit of having sat on a technical committee. All right. So what's included? Descriptions of roles and responsibilities within the specification writing team, checklists and step-by-step instructions, side-by-side examples, sample texts, timelines, documentation examples, because nothing is harder than the blank page or the blank screen. So one of the things that LP16 alleviates for you is, oh my gosh, I've never done a house of worship before. I don't know what to say about that. There's an example for a house of worship. I've never done a retail establishment before. There's a retail establishment description. It's not meant to provide, the idea is not to cut and paste, but the idea is here's an example that will get you started. And also questionnaires for client research, because sometimes you do actually have the opportunity to speak to the owner or at least to the architect and say, hey, what is it that we need? And sometimes it helps to know which questions to ask. And that is all I have for us today. Questions?
Can you give us a quick 35,000-foot overview of when we would want to use 0 to 10 versus Dolly versus DMX?
I can tell you what I do. So I use 0 to 10 when I have to, when it isn't going to be a problem to run that control wire, right? 0 to 10 volt is, in fact, an analog protocol that then has to be switched to a digital protocol to talk to a digital source and then switched back. So it's inherently less efficient, but it is what contractors know. So that's the main reason. When I am really dependent on the contractor to understand, or when when it just needs to be super simple for whatever the installation is, I use DMX or DALI specifically when I need to control more than one aspect of the luminaire at a time. So if I need to control color, temperature, and intensity, if I need to have color, temperature, intensity, daylight, on and on and on and on. If I'm integrating with multiple other systems, like an AV system and a shading system or an asset tracking system, for all of those, it makes more sense to use a digital protocol because all of those systems were developed digitally, and so then it's digital to digital. DMX specifically works really well when you need to address timing and more than one aspect of the system. The one thing that DALI does not do well is timing. So for example, if I need to change from warm to cool over the course of 2.5 minutes, DALI doesn't really have a good way to do that. I have to add another piece of equipment that can also speak DALI to do that. Whereas DMX, because it was developed for the entertainment industry, is designed to work on times, and it has to do with the way that the packets of information are fired. That's how I break it out. Any other questions? Yeah.
When you keep mentioning DALI, is that because you are not mentioning a specific manufacturer?
DALI stands for Digital Addressable Lighting Interface, and it is the overriding technology that Nlight, what does Cooper call it? I can't remember. It's because I can't remember what everybody calls it. But DALI is that overall thing. The one thing, the big blue manufacturer with the L does not use DALI because they put their own sort of umbrella over it. And for me, that's a problem because it means that systems outside of their world do not work within their world.
Right. Yeah, that's ultimately what I was asking.
Yeah. It's problematic. So you can, for example, you can take Nlight, or Enlighten, or Nlight, I can't remember. You can take the Acuity one or the Cooper one, and you could bring something in. Like you could bring a Wattstopper system in that spoke DALI, and a Cooper system in that spoke DALI, and there might be some conflict-y thing, but you could figure it out. You could, as long as they can both take a backnet gateway, you could figure out a way to make the two systems work. That other system, the big L guy, never. It's a closed loop. You can't get in there, and they do that for commercial reasons, and I find that problematic.
It's because DALI is
And,
international.
right, it's an international open protocol, and they don't want that. Other questions?
I just, on the OPR, what was the acronym?
Owner's project requirements. No problem. Ask for them and love them. They are also usually written in English. However, be aware that many times OPRs include language from previous projects that the project manager or the owner's rep has done, and so there can be all kinds of weird things in there. I saw one once that referred to fluorescent lamps and then said, like, fluorescent ballasts using fluorescent 35K T5 lamps using electronic ballasts, all loads should be 4,000K LED. I mean, like, sometimes it's like a kitchen sink of stuff. We'll just throw some lighting stuff in there and hope that people don't get too confused. Questions? Anything else? Thank you all. That's all I got.